So I finally made it up to the old new studio and I've more or less settled in. I must have gone up and down the stairs several hundred times, but it had to be done. The room's a lot warmer and drier than the previous space, and the CNC machines look a lot happier. I do have some footage of the move, so I may edit that into a separate video just for the patrons, but in this video I'm going to focus on assembling an X-axis linear actuator for the latest rendition of the CNC machine. These are matchy-fit HGR15 rails from Banggood, which I'm planning to use to assemble a basic linear actuator for a CNC X-axis that I've designed. I've been sent these to review, but I'll also show you how to check them for squareness once unpacked and how to install them. These rails are 600mm long, and they also came with a couple extra rail blocks, so 4 in total. Most rails at this size have 2 types of rail blocks, and the ones I'll be using on these are the CA type, while the other type you can get are the CC type. CA types use smaller M4 machine screws for mounting, are more box shaped and thicker, while the other type are shallower, wider and use a thread size up for mounting too. These could have definitely come better wrapped, and I think that's an issue with buying from Banggood. I'd really like to see them improve packaging for delicate items, but that said, the rails are quite thick and they haven't seemed to be damaged in transport. That said, they may have manufacturing errors, so now I'm going to show you how to check them once unpacked. This is a granite work surface which costs around £10. It's pretty flat for the price, and I've used it for various purposes, including sharpening chisels and checking tool flatness. To check your rails, it's quite simple to do. You simply place the rails on the clean granite to start with, checking they don't rock or wobble. Here I'm looking for twists or bows in the rails themselves. You may need to clean the rails a little to remove any grit or particles suspended in the oil these things are covered in. Once you're happy with the rails, you need to install the rail blocks, and using an engineer's straight edge or the flat surface from an engineer's square, check the surface of the rail blocks are parallel. Essentially, you want to know that the plate you're attaching onto these 4 points will not twist out of shape. Try to keep the rails parallel while doing this to mimic the actual setup, and check the blocks along the entire length of the rails, not just the center. These are pretty good. With the thinner rails, I've normally soaked the whole block in some kind of spirit to kind of break down the grease and get rid of any particles that may have got in, and then to reapply, but I think these are okay. To complete the assembly, I'll be using 2 pieces of 20x40 aluminium profile, a single 650mm SFU1605 ball screw, a FK12 end support, a 10 to 6mm motor coupler, a NEMA 23 stepper motor, and some 8mm thick end plates that I've designed and cut from Valchromat. Okay, I'm jumping ahead here. What I'm going to do is attach the plate, which will then have the Z-axis mounted to it, and you can see I've recessed some of the holes where the aluminium profile will run across. Now there's a procedure to do this to make sure that you keep this square to the X-axis, and so that the end plates, so the one over here and the one holding the stepper, are not fighting against how you attach this. And you should start by doing 2 things. The first thing is making sure that your nut housing is secure and these are held in place tightly. Essentially how this travels will inform how the rails will line up. The other thing is to make sure both your rails are loose, so you can see that they're moving around. Now the first thing I'm going to do is attach the plate to the nut housing, and again I'm doing everything on the granite worktop. This method assumes all the plates have been machined without massive errors from the original vector illustrations, and that plates with openings opposite each other are at least symmetrical. Once the nut housing is attached, I can push the rail blocks underneath and fit the countersunk M4 machine screws. The hole tolerances are quite high, with the M5 holes machined to 5.2mm and the M4 holes to 4mm. I'm not overly tightening everything just yet, as I want to move the Z carriage plate, nut block housing and 4 rail blocks towards the FK12 ball screw support. Working from one fixed end should help ensure the pieces maintain alignment from the end plate location. You may be tempted to throw a drill at the end and do this quickly, but the chuck may damage the steel and the weight of the drill could pull the ball screw off a little as well. Go slow and be patient, and you'll have strong and slightly achy hands by the end of this. Once the plate reached the FK12 support, I back off 1mm and make sure the rail ends roughly in line with the edge of the rail blocks. I can now secure the rail to the aluminium profile on the opposite end of the plate, but not too tight. I'm going to start by tightening these two here. I'll start to back off the plate so I can see the first set of machine screws on the rail by the end support, and tighten these up a little as well. I'll tighten that a little bit. Now I'm going to fully tighten the machine screws through the carriage plate to the nut block housing, and then the countersunk M4 socket screws to the rail blocks. And you don't want to over tighten them because you don't want to lose the thread, and that is possible. These are still just M4 socket screws, so the threads are quite small. Now I'm going to add, I'm using 20mm M4 machine screws for the inner mounting holes plus thick washers. I can feel them bottoming out a little, but they tighten up well enough. I then finish tightening up all the machine screws on the rail, working the carriage plate along the entire length from the FK12 end to the stepper end, always securing the rail screws closest to the blocks, moving along a little and repeating the process. This should result in the plate and blocks pulling the rails in line as they move along. Oh, that feels really good. The third set of machine screws were the first ones I tightened on the rails, and they'll need to be fully tightened now. I have to be careful not to thread the T-nuts. You may lose a couple and have to repeat the process until you know when to stop. After that, I can add some insert caps onto the rails to hide the screw heads, prevent grease and dust getting into the openings, and to generally neaten the appearance of the rails. In retrospect, I'd recommend putting these on when you have run the stepper motors and the entire machine is assembled, just in case something went wrong. They're pretty fiddly to remove. And finally, I check the entire assembly on the granite work block, and it seems flat and I can't feel anything rocking. I'm now using a digital bevel box to check that the carriage plate is flat and is not twisting while moving. It's pretty good. There's a 0.1mm deviation on the top left of the plate further along, but for my purposes it's not going to be a problem. I also check along the other direction of the plate, and that seems fine as well. I got lazy here and used a drill to move the plate along. Okay, that looks good. At the end, I'm moving the plate at the full speed of the drill, which is around 1600 RPM. And this is where I'll leave the video with some majestic clips of a fully assembled CNC machine performing a homing cycle, moving to the X and Y 0 position, and then the probe location where the spindle lowers while performing a probing cycle. If you'd like to check out the parts used in this video, I'll provide affiliated links in the description below, And if you want to support the channel and get first dibs on the manual I'm finally working on, it's looking great, I'll provide a link to my Patreon page in the description below. That leaves me with the final thing to say, which is thanks again for watching, and you'll catch me in the next one. Warm and dry.